of the forces at work on a moving car is called vehicle dynamics. Engineers need to consider the dynamics on a moving car when designing suspension and steering components. The basic reference points used by these engineers are the roll, pitch and yaw line. They are all derived from the vehicle centreline. Pitch is the tendency for the suspension to rise and fall under acceleration or braking. Roll is when the vehicle will try and turn on its longitudinal axis, and yaw describes how the vehicle will twist on its vertical axis. All of the vehicle's steering and suspension components need to be attached to the vehicle's chassis or body. In modern day monocoque vehicles, K or subframes provide a place to mount the many steering and suspension components. These help tie both sides of the vehicle together. Springs are the cornerstone of any suspension system. Their prime role is to help carry the weight of the vehicle, absorb road-induced bumps, and also provide the correct ride height. Linear rate springs have one defined spring rate per inch of deflection throughout their compressive range. Compressing a linear spring by 1 inch takes a specified force. Compressing it by 2 inches takes twice the force, while 3 inches takes 3 times the applied force, and so on. These springs are easily identified by the even coil spacing and uniform thickness of the spring wire. Variable or progressive rate springs provide a smooth and comfortable ride when the vehicle is unladen. They also improve stability and load carrying performance. These are designed to increase the spring rate as the load increases. This means the vehicle displays less tendency to bottom out, thus improving the ride comfort. It's an ideal solution for vehicles that only occasionally carry additional loads. Variable rate springs are easy to spot because they are not symmetrical. Typically, one end of the spring has tighter or more closely spaced coils. As the spring is compressed, the soft coil on the tightly wound side will collapse, coming into contact with each other. When this happens, the rest of the spring starts to compress at the second higher rate. Sometimes, to achieve the desired rate, 2 separate springs are used at the same time with a special perch mounted between them. Leaf springs are often found in solid axle commercial vehicles. They are designed as either a single or multiple leaf system. The curved spring assembly is designed to flatten as it is compressed. This characteristic tends to change its length. This is accommodated by the installation of shackles or spring hangers. These mount between the rear spring eye and the vehicle's chassis or body and allow movement of the spring as it is compressed. Multiple leaves are held together using a centre bolt and rebound clips. Torsion bars are a type of spring. Instead of arranged in a coil, the spring steel is shaped as a rod. One end of the bar is fixed to the chassis or subframe, with the other attached to either the upper or lower front control arm. As the suspension arm moves through its travel, torsional force is applied to the bar. It will return to its rest position once the force is removed. Torsion bars are used in four-wheel drives and commercial vehicles. They offer easy preload and ride height adjustments, but take up less vertical space than a coil spring. Torsion bars are pre-stressed, and as such, are designated left or right only. Coil springs are light, strong, and take up less space than leaf springs. They are used in both the front and rear of the vehicle. These are classed as linear or fixed and variable rate. The function of a coil spring can be better understood if we visualise it as a long, thin bar wound into a coil shape. Because the coiled wire twists during the spring's compression and extension cycles, the coil spring actually operates on the same principle as a torsion bar. Air suspension systems essentially replace a vehicle's spring with air chambers. The air springs are carefully designed rubber and fabric bellows, containing compressed air inflated to a certain pressure. By adding an onboard air compressor, sensors and electronic controls, air suspension systems provide several advantages over conventional springs, including near-instant tuning and the ability to adapt handling to different situations and varying load capability. The rubber bellows does not provide force or support load. The column of air does this when inflated. Although much more popular in heavy vehicle applications, air springs are still utilised by manufacturers like Audi and Land Rover in their current passenger vehicles. Hydraulic springs are not a new design and have been used in many light and heavy vehicle applications. They simply use the hydraulic cylinder, accumulator sphere to act as a spring. The sphere is divided by a flexible diaphragm. One half is charged with nitrogen at high pressure and the other is attached to the hydraulic cylinder and piston. As the vehicle's wheel and therefore its control arm follow the contours of the road, a linkage attached to the control arm forces hydraulic fluid into one side of the accumulator sphere. Flow is dampened through a set of valves before the fluid reaches the sphere. The fluid acts on the diaphragm, compressing the nitrogen. Once the force from the control arm is reduced, the nitrogen gas expands against the diaphragm, forcing hydraulic fluid past the control valving back into the cylinder. High pressure nitrogen is used due to its linear compression and expansion characteristics. This action is very similar to that of a shock and spring, but if we add a control module, hydraulic pump and reservoir, we can control ride height, spring preloads and dampening characteristics by adding, removing or changing the flow of hydraulic fluid. Rubber can absorb large amounts of energy with considerable weight savings over steel. Rubber springs work on compression and can be used as the main suspension spring or alongside the metal springs to improve the suspension's characteristics. The spring is installed between the K-frame and the top control arm. This arrangement of springs provides a rising rate effect, which is soft for small wheel movements but becomes harder as the spring deflects. The energy released from the rubber spring after deflection is considerably less than originally applied to it. Rubber bump stops used in many suspension systems aid the main spring against maximum deflection. Suspension systems have become highly sophisticated in the modern vehicle. It's important that we understand these basic components before any repair is made. Thanks for watching. Bye for now.